Hi guys. Now, let's talk about rational inequalities. What is a rational inequalities? A rational inequality is an inequality that involves a rational expression that is a fraction whose numerator and denominator are both polynomials. So here's the example of rational inequalities. X minus 3 over x plus 2 or is greater or equal to 0. First of all, let's identify its critical points, which is in the numerator is x is equals is x is equal to 3 because negative 3 becomes 3, positive 3, while the denominator is equals to negative 2. Now, let's create an interval for here, and because this thing identifies the when we check whether it's the legitimate of this thing. So 3 and negative 2. We'll create an interval here, which is negative infinite to negative 2, negative 2 to 3, and 3 towards infinite. So here in negative infinite, and negative 2 to 3, and 3 to all the way to infinite, we'll choose a testing ground for the of course we need substitution here. It should be so. On the first part, on this day, in this side, we'll at least say negative 3 because it's the safest one. At least one, or the nearest to the exact point. It depends on you. You can use decimals as well, but it's up to you. Again, we have to substitute the said number we have chosen. Let's say negative 3, negative 3 minus 3, and negative 3 plus 2. In here, negative 3 minus 3, negative 6. While here is negative 1. After this, we'll divide this, which is equal to 6, positive 6. Now, the question is 6 greater or equal than to 0? For sure, the answer would be yes, so it's correct. Now, the second one, let's substitute here with, let's say, 0. So, 0 minus 3 and 0 plus 2. Now, 0 minus 3, still negative 3. 0 plus 2, still 2. Now, divided would be negative 1.5. So, is it greater than 0? Is it greater or equal than 0? No. So, it will be X mark, so it's not included. Now, let's say 4. Now, 4 minus 3 is over 4 plus 2. The answer here is 1 over 6. And the answer would be 1 over 6. Is it greater or less equal to 0? Yes. Now, so we all got the exact answers, which is negative infinite and negative 2 and 3 and infinite. So how do we address this answer? So x is equal to negative infinite and 2 and a bracket 3 and infinite. That's the answer for here. The second equation would start here as instead of 0, there's, let's say we'll put 2. So here's the equation then. 3x minus 1 and over x minus 4 is greater than 2. First step is bring everything plus to one side and compare the rational equation with 0. So here, 3x minus 1 over x minus 4 and minus 2 is greater than 0. And into single fraction and find the critical denominator, which is common denominator, which is x minus 4. So 3x minus 1 minus 2 times x minus 4 over x minus 4 is greater than 0. Now, we should simplify it, so it becomes 3x minus 1 minus 2x plus 8 now and equal to x plus 7. Now, it becomes our equations. So x plus 7 over x minus 4 is greater than 0. So here's the checking of this one. Now, we'll use the 8, negative 8. So negative 8 plus 7. Again, we'll substitute here. Negative 8 minus 4. Now solve negative 1, negative 12, which becomes, when you divide it, it becomes positive. Is it greater than 0? Yeah, which is correct. Second one is this one, on the middle part. 0 plus 7 over 0 minus 4, so it becomes positive 7 over negative 4, which when it divides, it becomes negative. So is it greater to 0? No, so it's not. Now lastly, we choose 5 plus 7 and 5 minus 4. Sorry. 5 minus 4 becomes 12 over 1. And is it greater than 0? Yes, definitely. X is equal to negative infinite and 7 and 4 and infinite. That's the answer for this equation. Now, here here are the reminders. In the brackets and parentheses, be careful on that, as it reflects as a wrong bracket or a wrong parenthesis may cause confusion or make the equation entirely wrong. And beware of the integers. So if we put positive instead of negative, this may change this equation and may result in wrong. And that's it for this. That's for the lesson for today. And I hope you learned something from me. And thank you and good.